Hello everyone, my name is Yin Aosheng from Zhejiang University. I'm presenting attention for gloss-free sign language translation. Most sign language translation methods to date require the use of gloss annotations to provide additional supervision information. However, the acquisition of gloss is not easy. To solve this problem, we first perform an analysis of existing models to confirm how gloss annotations make sign language translation easier. We then propose gloss attention, which enables the model to keep its attention within video segments that have the same semantic locally, just as gloss help existing models do. Furthermore, we transfer the knowledge of sentence-to-sentence similarity from the neural language model to our gloss attention sign language translation network to help it understand the sign language video at the sentence level. This is the statistical data of some commonly used sign language dataset at present. We can see that the dataset without gloss has much more data than the dataset with gloss. This is because gloss annotation requires sign language experts to annotate, which tend to be expensive. Next, we try to analyze the role of gloss in sign language translation model training by analyzing the difference between the gloss-provided model and the gloss-free model. It can be seen that, on the one hand, the attention map of the gloss-supervised model is more diagonal than that of the gloss-free model. On the other hand, we can see that the ASD metric of the model is significantly lower than the model under the gloss-free setting when there is gloss supervision. This shows that gloss annotation do help the model understand sign language video at the sentence level. First, we design a new dynamic attention mechanism called gloss attention to inject inductive bias into the model so that it tends to pay attention to the content in the local semantic unit rather than others. Specifically, we first limited the number of frames each frame can pay attention to and set its initial attention frame to frames around it so that the model can be biased to focus on locally closed frames. However, the attention mechanism designed in this way is static and not flexible enough to handle the information that semantic boundary will. We then calculate the offset for each attention position according to the input query so that the position of the model's attention can be dynamic adjusted on the original basis. Secondly, to enable the model to understand the semantic of sign language videos at sentence level and the disambiguous local sign language segment, we transfer knowledge from language models trained with rich neural language resource to our models. Considering that there is a one-to-one semantic correspondence between neural language sentence and sign language videos, we can indirectly obtain the similarity relationship between the sign language videos by inputting neural language sentence into language models such as SentenceBERT. Using this similarity knowledge, we can enable the model to understand the semantic of sign language videos as a whole, which can partially replace the second aspect of the information provided by gloss. Experimental results on 3 datasets shows that the translation performance of the GASLT model exceeds the existing state-of-art method, which provides the effectiveness of our proposed method. Thank you for your attention and listening.